So here's part 2 of the polymer lab, and before we continue, I want to review what a polymer is, which is a long chain molecule. So what we're going to do is we're just going to represent the single unit of a polymer as this little dot right here. So if you can just start by saying this little single dot over here, this is going to be our monomer. Okay, and again, mono means we just have one of them. Now, there that goes. Over here, this is going to be our dimer. Okay, so we have our two units together, and this is going to be called a dimer. Di means two. So we have one, we have two. And of course, our polymer is going to be many, many units long. We're not going to draw that whole thing, but if you can imagine them all linked together like this. Okay, so this is going to be our polymer. And poly means many. This is a pretty good representation because we have these units that are linked together, and these little links right here are representations of the bonds that attach all of our monomers together into this polymer. Before we conclude our lab, I want to first go over another polymer that you might be familiar with, and this monomer is called polyethylene. So polyethylene. So ethylene actually is another name for ethene. So it's you might notice the ENE. So this is going to be a molecule that has a double bond in it. So ethylene actually equals ethene. It's just another name for ethene. Poly means many, so we have many ethenes that are attached together. Well, remember, ethene is a molecule that looks like this. It has two carbons, and it is linked together by a double bond, and it has these hydrogens on the edges like this. And if you take another ethene and add those two together, so this this ethene, consider this as a single dot like this. Okay, so we're going to combine this with another ethene. Okay, two carbons, double bond, and the rest are hydrogens. So here's my other ethene. Okay, if I combine them together, I'm going to get something that looks like this. Here's the one ethene, here's the second ethene, and they're going to be connected by this bond together. So let's draw and see what that would look like. So we have the carbon, double bond, carbon over here. From this ethene, we have the carbon, double bond, carbon from this ethene over here, and they're connected with the little bond that connects those two together, which is right there. Let's go ahead and attach the hydrogens, because if you remember, each carbon is able to form up to 4 bonds. This carbon right here has 1, 2, 3. It can actually have another one like this. This one has 1, 2, 3. It can have a fourth one like this. Okay, and this would continue on because we're going to connect this ethene to another ethene and this ethene to another ethene. Okay, so it's going to have a hydrogen here and a hydrogen here, and this will go on dot, 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 dot on both sides for a very long period of time, and this is times about 100,000. If you connect about 100,000 of these monomers of ethene together, you will get what's called polyethylene. Another name for polyethylene is called plastic. Polyethylene is a type of plastic, and plastic is a polymer coming from these ethenes. And polyethylene might sound familiar to you. You might actually have seen their symbols and their plastic symbols because we find them on plastic containers that can be recycled. If you've seen the symbol that looks like this, like that, and it has a 1. You might have also seen on some containers, they might have the letters P, E, T, E. The PE stands for polyethylene. So it's poly, there's the P from the poly, and it's polyethylene. And these 1 containers, you find these are your clear plastic containers like on water bottles or soda bottles. So this is going to be an example of your water bottle. There's another polyethylene product, and you might have seen this too. So the symbol looks like this, and there's going to be a 2 on the inside of it. And this is going to be HDPE. This is your high density polyethylene, the HD, high density polyethylene. And these are going to be your milk bottles. So plastic is actually a polymer. It's a polymer of ethenes, and so therefore it's called polyethylene. Okay, let's get back to our lab, which we did part 1 of. And I have the bag right here, and we're going to write all this information down. So this is our sodium polyacrylate. Let's go ahead and say that this polyethylene is item number 1, and item number 2 is going to be the sodium polyacrylate. So you notice that we see the word poly again. Sodium polyacrylate. Well, the acrylate molecule looks like this. It's actually a long molecule by itself. Okay, it has a CH2, double bond with a C, H, single bond, C, double bond O, and it ends with an oxygen and a negative charge. And in the ion form, the sodium is able to bind onto this, so it's therefore called sodium acrylate. Here is the acrylate. And if we get 2 of these together, it will look like this. Okay, let's connect the CH right here. We're going to have the CH like this, and then we're going to have this also another CH over here, CO, CO with the O's. So this end of the molecule has not changed. However, the other end of the molecule has changed. And this CH is going to connect over to this CH2 over here. But if you remember, carbon's able to form 4 bonds. So this carbon is attached to 1, 2, 3, because the hydrogen is a 3rd bond over here. And the 4th one is branching over here. And here's the other CH2 for this one. So this carbon's attached to 1, 2, 3, and then etc. 4. So this is the dimer of the sodium polyacrylate, and if you continue it more and more and more, it forms the polyacrylate, sodium polyacrylate. Again, poly means many. Here's the monomer, here's the dimer. We're not going to draw the polymer because that would be too much. So let's go ahead and let's take a look and see how much the bag weighed. The bag weighed a total of 12.30 grams. So 12.30 grams. The bag and the powder weighed 16.25 grams. So we have the bag plus the powder, which was the sodium polyacrylate, and this was 16.25 grams. Okay, so how much was just the powder, well, we have to subtract those. How much was the sodium polyacrylate? We get a calculator. We have 16.25 minus 12.30, and we get 3.95. So we had 3.95 grams of powder. Okay, and then to that, we added about 1,347 grams was the total mass of this. So if we take the bag, the powder, and the water at being 1,347 grams, okay, if we subtract the bag and the powder of 16.25 grams, let's just say it's 16 grams. Okay, so here's the bag plus the powder plus the water. If we subtract the mass of the bag and the powder, we will be able to get the mass of the water that was added to this. So 1347 minus 16 gives me, that means there's 1,331 grams of water that was added to the bag. So what I want to do now is I want to say, well, how many more times of its weight can it hold in water? We're going to take this, which is the 1,331 grams of water. Okay, this is the mass of the water. And we divide this by the mass of the powder, which is 3.95 grams of the powder. So we have 1,331 divided by 3.95. This gives us about 337. We're going to just round to 3 digits. 337. 337. What does this number mean? This means that this powder holds 337 times its mass in water, which is pretty good. That's pretty close to what I would expect. Anywhere between 200 and 400 is what we'd expect for this. So we probably could have held a little bit more water. So if you have a diaper, you have a tiny amount of powder, and that can hold about 337 times its mass in water, or its mass in pee, and pee is just mostly water anyway. So this powder has the amazing ability, because it's a polymer, and it has lots of spaces in it. Okay, so I'm just going to draw these kind of squiggles like this. And these spaces right here, this is what's holding the water. The space holds the water. And that's what gives this sodium polyacrylate its unique property of being able to hold so much of its mass in water, and it's because of all these spaces. So we should probably say all these spaces. They hold that water in. So that's part 2 of this lab. There is another part coming up.